Thank you for that introduction. Just real quick, my name is Poulsgaard. I'm a partner in GXN. We're the independent research company of 3XN Architects.
And my name is Thor, and I'm head of computational design at Banke.
And we're here to talk to you about this tagline here. If AM is the answer, what is the question? We're talking about this from the realm of construction and architecture. We're going to be talking about some of the challenges that we're facing in architecture and what we think additive manufacturing, 3D printing might be able to do about this. So if you want to talk about challenges, this is a great place to start. This is China, Shanghai, 1987. And this is Shanghai 2013. Oh, let's see if it works. There we go. 26 years later, right? Shows what 26 years can do. It's amazing how much has been constructed in this city over that period. Shanghai is the largest city in the world. It's one of the fastest growing cities in the world. It's been growing with 10% every year for the last 20 years. We have a massive construction challenge facing us. Another way to put this into perspective is the fact that China, as a country, utilized and used as much concrete for 3 years, from 2011 to 2014, as the USA did in all of the 20th century. These numbers are mind-boggling. The world population is growing. We're going to be 6.7 billion on the planet in 2040. All of these people are moving to the cities. We're seeing sprawl like this. Of course, all these buildings will need materials. They will need cement, they will need metal, they will need rebar, and they will need marble, for example. So this is a marble mine in Carrara in Italy. It's from a film that's called The Anthropocene by a photographer called Edward Butinsky, and it's really worth a watch if you want to see how the way we are constructing and manufacturing things around us impact the world. We are literally moving mountains to build the cities around us. And according to the United Nations Environmental Protection Program, we have to double the amount of floor space available on the planet in the next 40 years. This is nuts. Construction is really very much part of the problem, what we're facing. The construction industry in Denmark is utilizing about almost 40% of all our materials in society. We're generating 37, almost 40 again, percent of all waste. And we're responsible for 40% of CO2 emissions. So, this is sort of a picture of how we are dealing with this in construction at the moment. Business as usual will not do, but what are we going to do about this? And of course, and you heard this before, the sixth assessment report is only adding more urgency to these challenges that we're facing here. There's a lot of bad news coming out of this. I'm just going to share the one piece of good news that was in there, and that is that if we can actually bring down emissions and reach net zero, there's a great and very big chance, and a lot of research pointing towards the fact that that will actually also stop warming. If we can reach net zero, we will stop and even be able to reverse warming. So decarbonization is really part of the challenge that we're all facing, especially in construction right now. So, is this going to save us? I'm not sure. I'm not sure if Thor is sure. We've seen a lot of great ideas out here for what this might do. But if this is going to save us, we think this needs to address some of the key challenges that we have in construction today, and we're not really seeing that, and that's what we want to talk to you guys about, the challenges that we should all be thinking about and addressing. Digitization in and of itself is not enough. We've just heard a lot of great reasons for why that is. We can see that even though the construction industry has invested heavily in computers and in IT, we don't really see any productivity growth. So this led economist Robert Solow to come up with this sentence. You can see the computer aids everywhere, but in the productivity statistics. That's 1987. Same year he got the Nobel Prize in economics. This same productivity paradox is still existing today, and if some of you work in construction, you might have seen this. Construction is that orange line flatlining down there in the bottom, even going down sometimes. Labor productivity in construction has been flatlining for the last 50 years. So is 3D printing going to change that? Let's see about that. We do have a question, that is, how did we get here? I think Thor will try and guide you through that.
Thank you so much, Kåre. Through history, every single time we have seen like important materials or building techniques being applied, we have seen great leap in the construction history. And through time, we have been using several types of materials. All of these materials has advantages, disadvantages. And I think what is really interesting now is that we are really at a digital age where there's a lot of speed on the research and development on the material side. But the question is, have we seen this leap just yet? If we take some time back and talk about material and the importance of material, here's I think a great example from the Native Americans using buffalo skins as a type of textile. They could use this to have these incredible flexible structures that they could actually modify them depending on the climate. They could use it to wrap around a scaffold. They could take down and they could move around and according to the natural resources. If we look at some building techniques, I want to zoom in on the stone brick. Here's one of the first standing examples we know today. This is from Greece, around 3,000 years ago. And what we're seeing here is like a bridge with an arch. There's no mortar or anything. But what this suddenly opens up for is the Romans that actually enhanced this technique, and not just building wonderful architecture, but also these amazing structures that made it possible for them to use natural resources in a complete new way. Both transportation of humans, but actually more important, transportation of water, which had a huge impact on the way they could form cities and also the health of people. So, before the Renaissance, architecture, engineering, and craftsmanship was joined into one master builder, so to say. It was a person or a group of people that had this same knowledge. So the flow, so to say, was very short. After the Renaissance, there was a split between these. There was new professions coming in, and the design process became more and more complex. I think there's a great potential for additive manufacturing actually looking into this. What we do today is we have very advanced computational design, both workflows and tools, where we can simulate environmental performances. We can have highly information-heavy models, and we can have great collaboration across different professions. So just as an example, this is a structural model looking into structural performance, and actually also looking into, like this slide here, looking into the a change in what is it called? Material, like if the material is going out of place, so to say, in this folded structure. So, but the point is, many times when we go to the construction side, this is where it all ends up. And this place has actually not had the great leap yet. It's actually a lot of manual procedures, and if one of the many different professions in this process, if we don't get it right, then we actually lose a lot of value. So the question, I think, is really what is it that we want to resolve with additive manufacturing through this process? A lot of research and development is going into a strategy that's about put the entire architecture through the nozzle. You could say if that's right or not. I think the potential with additive manufacturing is much, much greater. So can additive manufacturing unite craftsmanship, engineering, through our the last year, Kåre and I have been working together with AM Hub on a project, starting to reveal some of these potentials. And one of the examples that we showed was actually a project that sometimes it helps just to get some inspiration from outside. This is a highly manual analog project, but I think in terms of the process, it has some great findings that might be great inspiration for additive manufacturing and the role for additive manufacturing. So I don't know if you know this project. It's about 10 years ago from this really great Spanish studio. So I don't know if you can see it, but this guy here is placing a lot of hay balls in and actually stacking it. You could maybe think about additive manufacturing as the hay in this example. The way that they started to sketch this was actually that the hay is built up and as the negative structure. So they are actually building the inverse of the whole thing. Then afterwards, then they are making a wall with dirt and then pouring concrete in. Today we would probably use a more sustainable material, and I think there's many possibilities for that. And then we simply cut the structure through in one end. It's very difficult to see, but this is actually where time totally stops, because and things get very interesting, because this is where the collaboration starts. This is a cow that's standing here, and right now this guy here, he is he's very interested to see if the cow will actually eat the hay. And actually the cow does. It eats its way through. It might have visits of some of its friends also, and I don't know how long time it took. But now I'm coming to my point, and I'm sorry for the images. It could be a little bit lighter, but I think this is actually some really incredible spaces that suddenly emerges from this. And my point is that these spaces here would, how could you arrive at this, if you didn't have that process with the hay and the guy that was helping the cow and that whole collaboration. And I think we need to find those opportunities with additive manufacturing where it's actually opening up new possibilities and not just trying to fix what we already have and fix it maybe in a worse place. Of course, in architects, that always help with a good view. That's always the thing. So this is actually some of our early work, through the process working with AM Hub. And here, this was some examples of how additive manufacturing could be used, not maybe as the whole architecture through the nozzle, but actually going in and using some of the techniques, collaborations and processes already known, and actually also opening up for craftsmanship. Maybe just going through the first one here that's about a node structure that's opening up for these highly digital crafted joints, but used as this scaffolding system. The other one is a printed textile that can then be inflated, opening up for the possibility to reuse the scaffolding or keep it as a structure that is then being applied with sheet material that can create these very light structures. And the last example is a printed structure that can hold installation, technical installations, but actually being used as a scaffolding for a bricklayer that then, for him, opens up new possibilities for making incredible structures that would not be possible for him to do before. So creating value to that profession.
Sure. So we're working 3XN, GXN, BIG, and Danish AM Hub to explore what these techniques can do in construction at the moment. This has to be a little bit of an advertisement for next year when you can see the actual design results of this. But before going into that, I think what we've been thinking about is, what's the role of 3D printing in construction? What can we actually go in? And one of the things we're looking at is what construction does well, and what construction does less well, and what construction is really, really bad at as well. And looking for places where 3D printing might fit in and allow us to do new things. So every building is a prototype. It really is. There's a lot of research and innovation going on whenever we construct something. But every building is also massively expensive. It takes up to 10 years to build. There's a whole team of people. There's a lot of ego. In this environment, risks scale very quickly. There's a lot of things you get to do. There's certainly a lot of things you don't get to do. You don't get to ask too many open-ended questions. You don't get to experiment too much with new materials, new approaches, and so on. And that's because construction as it is today is really predicated on economies of scale. And that comes with a lot of benefits. We try to modularize. We try to industrialize production. It also comes with some challenges, and this is where we can see space for additive manufacturing. This is one of the first social housing blocks in Denmark. It's really a triumph of the Danish welfare state and construction working together. About 15 years, from 45 till about 1960, the construction sector innovated concrete, a modular concrete element fabrication and construction. We love this in Denmark. We're still building a lot with this. And for the period from 1960 to 1980, we built a ton of these buildings, pretty much all using the same techniques. We figured out sometimes during the 70s that maybe this type of construction wasn't the best. And today the Danish government has mandated by law that we tear down 1 million square meters of these buildings to build another 700,000 square meters of other buildings to try and change the social makeup of these areas. It's going to be very wasteful. It's going to tear some communities apart. It's going to be a big problem. And this is one of the first challenges we see with construction, with these economies of scale, is that we get locked in to certain ways of producing, and we continue these ways of producing and building even when we know they're not necessarily the best that we're doing. This comes with other challenges that we are replicating today. So this is one of the new areas that we're building here in Copenhagen. Our team in GXN had a look at one of these areas to look at the variation in the apartment. So there was a good couple of days trawling through real estate web pages, finding all the floor plans and looking at it. And what we can see is just the uniformity of the product of what we're building today. There's 1,000 of these floor plans. It's pretty much all the same plan. It's the same layout. It's 2 to 3 bedrooms, living rooms around it. Second challenge of construction, when we're doing it as we're doing it today, is the pure uniformity of the product, and the fact that that might not meet all the demands and needs we have out in the business. That is, of course, if we're even building. If we're looking into the real estate economics part of this, we know that there's a lot of underutilized land out there. There's a lot of land that's waiting to be developed. You've seen this, I'm sure, wherever you're coming from. And there's a lot of sort of large-scale efforts going on in between development. So you saw just how much is being constructed out here. This place, this harbor, I live right next door here for 10 years, has been empty for 10 years while the companies who are constructing out here has been maturing it. There's a lot of underutilized land at large scale, and of course if we look into the cities, which we did with Big and AM Hub, there's also a lot of underutilized land at small scale. Plots that for some reason or another are either too small or too weird, or lie into weird different things, so that they cannot be used under the current model. So what might we do with all of these things? What can we do if we want to break with these economies of scale? Well, something can happen when we work at smaller scales. This is from 2007. This is a GXN pavilion. It was part of an exhibition called The New Frontier in Bio-Based Architecture at Louisiana. It's not 3D printed, I should say. But it was an attempt to see if we could find ways of utilizing bio-based materials to create a dynamic and engaging architectural language. And so this is not steel. This is a flax fiber put together with a bio-based resin with mycelium inside it. And so it's a way of trying to substitute wasteful and polluting materials with new biological materials. We're doing this at small scale because if you experiment at small scale and fuck up, it's not really going to hit us as hard as it is at the large building scale. What happens, though, is that when we're working at this scale, we can learn things that we can then pop into our bigger buildings. And actually, some of the bio-based approaches from this found its way into a facade of a building 3XN did 2 years later. So we can experiment and then scale. And of course, we can work in ways, and this is where additive manufacturing again becomes interesting, where design, material innovation, and construction is all folded into one process. Working with materials and the material waste streams that are out there is something that we are very engaged with and excited about in this project. I don't want to talk too much about it. These are just some waste streams from Copenhagen that could potentially be printed with. But the concept of what we're coming out with is that idea of trying to work with the waste streams we have in the city. And we have the material waste that's coming from what we're throwing out. But we also have the spatial waste that's coming from these underutilized plots of land that are either under development or won't be developed because they simply don't fit. Additive manufacturing, in our vision, can be the thing that can tie these two waste streams together and create new experiments, new structures, new ways of thinking about what we can do in the built environment. So what might we do with these plots of land? Well, we can certainly realize untapped value for the developers rather than have an empty plot of land lying around for 5 years, 10 years while they're waiting to develop their thing. Why not use printing to create a structure, to create life, invite a market out there, whatever it is? We can really utilize this notion of experimenting and then scaling, working with the things that additive manufacturing allows us to do, which is variation and low cost, material innovation, experimenting with materials that can bring down embodied carbon, decarbonization. And of course, work with the fact that when we're working at a smaller scale, we can really reduce risks and thereby make a lot more experiments. And we're doing these experiments at the moment. Again, please come back next year and have a look at this. Just want to end on our friend Cedric Price. If additive manufacturing is the answer, what is the question? Well, here's some of the questions that we think we should all be asking ourselves, which is, how can we build in ways that respect planetary boundaries? How can we bring digital architecture all the way from the architecture studio out into the construction site? How can we capture lost value, either through material waste or spatial waste, in new ways of collaboration? And how might we actually speed up the learning in architecture and construction and have continuous variation and learning through things? And these are all things I think additive manufacturing can help us with. We're very delighted to hear you guys' versions of this, so please come and find us if you're interested. And thank you for listening.